Hey everyone, welcome back to our today's Python programming series. Today we are diving a little deeper into exploratory data analysis or EDA. We will focus on spotting outliers, understanding data distributions, and doing some more advanced dataset cleaning. So let's get started. First thing, let's load up our dataset and the libraries we need. We are using an SPSS dataset for this example. Make sure you have got pandas, matplotlib, keyboard, and plotly installed. Let's install them if you haven't already. So I have already installed. So now let's load our data and take a quick look at it to see what we are working with. And this is our dataset: age, sex, BMI, children, smoker, region, charges, and new charges. And there's null counts is non-null for every group and dataset. So now we're talking about outliers. Outliers are those values that are way off compared to most of the data. They can skew our analysis, so it's helpful to identify and understand them. If we will look at outliers using box plot, which show values that are far from the rest. So this is for the code box plot, and box plot highlights outliers beyond the whisker of the box. Box itself represents the middle 50% of the data. So let's run it, and you're seeing here the box plot for age and BMI, and this is for charges. And there's also another way to detect outliers is using Z-score. The Z-score tells us how far a value is from the mean in items of standard deviations. A Z-score above 3 or below -3 is typically considered as outlier. So make a code for the Z-score. The code for Z-score is equal to np.abs Z-score dataset is charge and BMI. And then how to identify rows with Z-scores is greater than 3, and this is outliers. Z-score is greater than 3 and X is 1, and then just run this code, and you're seeing here outliers detected empty data frame. That means there isn't any outliers in the data frame. So now let's look at the distribution for our data. Understanding distribution helps us to see if the data is skewed or normally distributed. We will use histograms and kernel density estimation (KDE) plots for this. So this is the following code: plot histogram with KDE for distribution analysis. And for that I just use for I column is BMI start from 1, and then plot, subplot, and SNS. Just run it, and you're seeing some histogram. This is for the distribution of age, and this is for the distribution of charges, and this is for the distribution of BMI. So now if we have missing data, handling it properly is crucial. Last time we filled missing values with the median, but let's try a different approach today. We will use forward fill, which fills missing values with the previous row's values, or backward fill, which fills them with the next row values. So for that we need a code, and this is the following code. This code tells us about forward missing value dataset.fill in a method FFILL forward fill, and this is for backward missing value fill in a method BFILL backward fill, and then print data format fill, and just run it, and you're seeing here this is for forward fill result, and this for backward fill result. And now, so for numerical data we can also use mean or more to fill in missing values, especially if the value are continuous. So for that the following code is this: data mean field, data set dot fill in a data set dot mean, and just run it, and you are seeing here the results. And that's for today. Today we covered some more advanced EDA technique. identifying outliers with boxplot, and this course analyzing distribution with histograms and KDE plots, and using various methods of handle missing data. These are essential tools that can give you deeper insights into your data before you even begin modeling. So thanks for watching and see you next time. Stay tuned for more videos in this Python series. See you in the next one. Bye bye.